but my hope will never die.
Encapsulation is one of the most basic concepts of OOP, and it is essentially just the bundling of data and methods that work on attributes in one area. Encapsulation is needed for many other concepts to work, e.g. data hiding. For example, if we have a private attribute that we need to modify, the only way to modify it is to make a public setter method within the same class. By nature, this is encapsulation. The attribute and its modifier are stored within the same class. Inheritance involves inheriting attributes and methods from a predefined class to create a subclass. The class being inherited from is known as the parent class, while the subclass is known as the child class. This is particularly useful when trying to instantiate different objects with similar properties. Inheritance allows for more complex objects to be derived from a base, while keeping them separate. For example, consider we have a class called car, and we want to create a lorry class. We would need all the attributes of the car, with additional attributes like the loading capacity, etc., etc. Inheritance can be used here to save time and complexity by giving the lorry class all the attributes of the car, with the ability to add external setters and getters. Data hiding is another OOP technique which involves hiding the data stored within an object, such as its attributes and methods, from anything external to that specific class. The concept of data hiding is the exact reason why we need setters and getters in programming. Since private attributes can only be accessed by class members, we need to call a public method that is a class member in order to edit the private attribute. This is particularly useful when working with sensitive information. Such information needs to be changed, however it should not be accessible or changeable outside of the specific method.
Polymorphism is our final technique, and it refers to the ability for objects and data to be processed differently through the same interface. For example, let's take the example of a method that calculates area. For a square, this would simply be its side length squared. For a rectangle, it is its width multiplied by its height, and for a triangle, it is a half base multiplied by height. As you can see, these are different objects, and so usually we would have to create different methods for calculating the area for each of them. With polymorphism, however, we can make one area method, and then redefine it for a separate object. This way the area method is able to calculate different areas based on the data received, thus integrating polymorphism for a single function.